Okay, so this section is Chapter 3, compound statements. And as with most of the other lessons on here, I'm going to assume that you do have at least a nominal background in compound statements or truth tables. So looking at number 1, determine the conjunction that corresponds to the given table. Remember, if you're using a conjunction in mathematical parlance would be and this is the symbol for and. If we are using or, then it would be called a disjunction, and that would be addressed in problem number 2. So a conjunction involves the use of the operator and. The conjunction would be not P and not Q. So not P and not Q would actually go into this top row, third column. So let's do a row by row analysis. Our conjunction would change our first 2 entries, right? If we claim that the result is not P and not Q, then for each row, P and Q would have to take the opposite value. So if we look at row number 1, P would be true and Q would be true, then P and Q would be true. The second row, P would have to be true and Q would be false. And if you have a false statement and a true statement joined together with a conjunction, then that would be a false statement. Remember that in order for a conjunction to be true, both the hypothesis and the conclusion must be true. Same thing with row 3. P would take on the value false, Q would take on the value true, and since these are not both true, then that compound statement would be false. And then the fourth row. On row 4, Q would have to be false, P would also have to be false, and false combined with and would give you a false statement. Number 2, essentially the same type of problem, except this time we're looking at the disjunction, and disjunction uses the word or for the truth tables, and or, here's a notation for P or Q, and that happens to be the solution here. This would have to be P or Q. So let's take a look at each row. If P is false and Q is false, then P or Q would have to be false. Remember that P or Q is true if at least one of the letters P or Q is true. Row 2, if you have a false statement or a true statement combined, then that would be false or true. Well, that would be true, because if any part of an or statement is true, the whole thing is true. Row 3, I have true or false. Again, if any part of an or statement is true, then the disjunction is true. And then for the fourth row, true or true, well, since both of those are true, then the disjunction would be true. Number 3. This one was a lot more complex, and I had to play around with it to finally get it to match up. This is a conjunction. This is a disjunction of conjunctions. So a disjunction of conjunctions would have the and on both sides separated by an or in the middle. So that would be a disjunction of conjunctions. Let's go through this to see why this would be true. On the left side, I have P and Q. We'll go to row 1. If P and Q are both false, then we know the left side of the or is false. And then on the other side, not P would be true, and Q would be false. Well, a true and a false statement is false, so we would have false or false. So false or false would give us a false disjunction. Row 2, P and Q. Well, if P is false and Q is true, then P and Q would be false. So on the left side, we would have false. On the right side, not P would be true and Q would be true. Well, then that means not P and Q would be true. So on the left side, we would have a false statement. And on the right side, we would have a true statement, which means that we have false or true. And again, if any part of an or statement is true, then the whole thing is true. Third row, P is true, Q is false. True and false on the left side of the disjunction would give us a false statement, a false compound statement. And then on the right side, we would have not P and Q, which would be false and false. So on one side, we would have false. On the other side, false. Well, false or false would make the disjunction false. And finally, row 4. If P and Q are both true, then we would have true on the left side. Not P would be false. Q would be true. So that would be a false statement on the right side. But since it's an or statement, the disjunction would be true because we do know that the left side, P and Q, would be true. Okay, number 4 says to refer to the table in number 3 to determine the conjunction of disjunctions to complete the table. I wrote out sort of a long scenario here. The solution on number 4 would be not P or Q and P or Q. These tables usually require a great deal of practice with working with conjunctions and disjunctions. There is certainly nothing wrong with trial and error. Actually, on the last 2, I used trial and error to an extent. Eventually, you do become more fluid. I was admittedly out of practice. It's been a while since I had taught finite math, so I had to brush up on my skills there as well, so I can sympathize. But I knew that to get a true statement, I knew that both sides had to be true. We have a conjunction separating the two disjunctions, so I know that in order to have a true statement in the final analysis, the left side would have to be true and the right side would have to be true. And since we have disjunctions on each side, we couldn't have both sides of the or statement to be false on each side. So starting with that, I just worked my way through and figured out that it was not P or Q and P or Q. Number 5, negate and simplify P and not Q. I am not a fan of memorizing formulas just for the sake of memorizing formulas. I do like to, if possible, convert all formulas to some sort of a common sense, practical reasoning scheme. But if you negate P and not Q, DeMorgan's law would say that it would have to be not P or Q. Okay, that's simple enough if you are into just rote memorization. But here's the way I like to think of these. If you negate P and not Q, that means you cannot have P and you cannot have not Q. That means you will not have one or the other, which means you will not have P or you will not have not Q. So think about that, and hopefully after a little time it will sink in and make sense. But if nothing else, you know, if you're a student just trying to get through the course, if you just want to memorize DeMorgan's law, that would certainly do it. But again, if you cannot have both, basically, if you cannot have both P and not Q, then that means you're going to have to not have one or the other. Number 6, negate and simplify P or not Q. If you cannot have A or B, for example, then you cannot have both. So the negation would be not P and not Q, which simplifies to not P and Q. So I'll just say it again. You know, if you're into memorizing formulas or you're just trying to pass the test, a simple application of DeMorgan's law would apply. But if you are told that you cannot have A or B, that means you cannot have either one. You can't have one and you can't have the other. So that's why it simplifies to an and statement, a conjunction. Number 7, negate and simplify P and not Q or R. When solving these, I like to work within parentheses as much as possible. Just think of this as basically one item. So if I cannot have both sides, let's see, if I cannot have both sides of the and operator, in other words, I can't have P and I cannot have not Q or R. That means I have to forfeit one or the other. That means I cannot have P or I cannot have the other side, right? Not Q or R. That gives me, if I use DeMorgan's theorem again, we would basically end up distributing the and symbol across. So not P or not Q or R would end up being not P or not Q or not R, which simplifies to not P or Q and not R. Number 8, negate and simplify P and R or not Q or R. Well, again, we have a disjunction. If I cannot have the left side or the right side, then I cannot have either one, right? I cannot have the left side and I cannot have the right side. And then again, DeMorgan's theorem laws would work just fine. On the left side, not P and R would be not P or not R. Of course, the and symbol would just transfer over. And then I have to negate the other side. So not Q or R would be not Q and not R. Simplifying gives me not P or not R and Q and not R. Number 9, what is the converse of the statement if X is odd, then X squared is odd? If we do a converse statement, if you have a conditional statement that says if P then Q, then the converse would switch the antecedent and the conclusion. It would be if Q then P. Well, X is odd is the P, X squared is odd is the Q statement. So the converse would simply be if X squared is odd, then X is odd. Number 10, what is the contrapositive of the statement? Again, if your conditional statement is P implies Q, then the contrapositive not only switches P and Q, but it also negates both of them as well. So this would actually be a not Q implies not P. Not Q would be X squared is not odd, then X is not odd. So that would be the contrapositive of that statement.